Hello everyone. Hope you all are enjoying your studies. Here in this series, we are going to understand various forms of graph in motion. We will be studying various situations and their graphical representation. We will be observing the changes taking place in displacement time graph, velocity time graph, and acceleration time. At first, we are trying to understand graph for body at rest. Body at rest means its displacement or distance from origin is not changing but the time is changing. Under this situation, body does not have any motion I, its velocity or speed is zero. It means from the starting of time of observation till the end of time, body has not moved. Here we are to observe graph of distance versus time graph for any object or body at rest. Consider a situation in which a body is at a distance 4 meters from the origin and the time is passing. If we work on graph points, then we will find that as the time is changing, but the position of the body is not changing. Here in graph values you can observe time is changing from 0 to 2, 4, 6, 8, 10 and so on, but at all the time the distance is 4 meters only. The graph of a body at rest is a straight line parallel to x-axis or time axis. Now heading towards next segment. Graph for body moving with constant velocity. Constant velocity means object is moving with same speed or velocity, but the time is changing. Let's consider a body is moving with constant speed or velocity along a straight line without changing direction. Or in other words, body is traveling equal distance in equal interval of time, however small the interval may be. Let's consider the data for the situation and a graph for body moving with constant velocity. Here the graph points shows that time is changing uniformly with interval of 2 seconds, that is 0, 2, 4, 6, 8, 10, 12 and so on. While we look for velocity part, then velocity remains 30 meters per second at all the point of time. So once again plotting the points on graph shows straight parallel line. Hence we can conclude that the graph of constant velocity is a straight line parallel to the time axis, that is x-axis. From the graph it can be understood that time is changing but the speed is not changing or remains the same, that is 30 meters per second. Heading towards yet another section, that is a t graph. You have correctly guessed, it's acceleration versus time graph. Graphs of acceleration versus time can be constant, increasing or decreasing. Here, we are focusing firstly on graph for constant acceleration. Again, you all can notice the values for time is changing uniformly with values 0, 2, 4, 6, 8 and so on. While the acceleration kept constant, that here we have kept acceleration as 4 meters per second square. Once again we can find the graph of constant acceleration is a straight line parallel to the time axis. At this point, if we further go in more details, then can have a look how is velocity and displacement is affected. At first have a look at graph of constant velocity, that is when acceleration is 0. This time along with constant velocity, let's have an eye on how is displacement changing. The data for the graph is obtained by using elementary idea of velocity and displacement. Here on careful observation of two graphs, we can surely draw the conclusion that at constant velocity, the displacement of body is uniformly increasing. Here for these graph acceleration is 0 while velocity is positive, that is there is no change of direction. Last graph was obtained on the condition when acceleration is 0. Now let's have a look how And what are the changes in displacement when there is constant acceleration? Here we can draw conclusion that when there is some acceleration, then change in displacement is non-uniform. You can easily observe from both table and graph that change in time is uniform, but displacement is non-uniform.
In this series we have observed first graph for body at rest, second graph for body traveling at constant velocity, third graph for constant acceleration, fourth graph for displacement under constant velocity and zero acceleration, fifth graph for displacement under constant acceleration. Hope you have developed some understanding regarding some graph. Let's meet once again in another part of graph.